Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1. That is Probability, brought to you by Vitan Sir. Now, in this tutorial, we are going to start with the definitions of probability. The first definition is known as the mathematical definition, also known as the classical definition of the probability. The second definition is statistical definition, also known as the empirical definition. In this tutorial, I am going to explain about the mathematical definition first. So the mathematical definition of the probability, but before I start with the mathematical definition, I need to explain some important terms. The first term is the equiprobable events. Now, when the chances of happening of two or more events are same, in essence, there is no reason to believe that one event has better chance of happening than the rest of the events, then we can say that these events are equiprobable events. Basically means their probability of happening is same, equal, so we call them equiprobable events. Let us take an example here. All 6 sides of a die has equal chance of happening, and therefore we can call those events the equiprobable events. Okay, so equiprobable event means that all the events of a sample space or all the events of a set or group has equal chances of happening. Their value of probability is equal. Second term which we need to understand before the definition is the favorable outcomes. When out of all the elementary outcomes in a sample space of a random experiment, a set of outcomes indicate happening of particular event A, a set of outcomes which indicate the happening of a particular event A, then those set of outcomes are called favorable events. So the favorable outcomes or favorable events are the outcomes which indicate the happening of a particular event A out of the sample space of a random experiment. If I want to take an example here, if event A indicates getting odd numbers by throwing a die, then favorable outcomes for event A will be 1, 3 and 5. Okay, so getting my point here, the sample space of throwing a die is 1, 2, 3, 4, 5, 6, but the event A indicates getting odd numbers. So odd numbers here are 1, 3 and 5. So that's favorable outcomes. Now let us move on towards the mathematical definition of probability. It's a bit longer, but you need to remember the definition verbatim as it is written. Suppose there are total n outcomes in the finite sample space of a random experiment, which are mutually exclusive, exhaustive and equiprobable. If m outcomes among them are favorable for happening of an event A, then the probability of the event A is written as m upon n. The probability of event A is denoted by probability A. Okay, so the n are the total outcomes, m are the favorable outcomes, then the probability is m upon a. Now this is something which we have studied in 10th, but this is just kind of a revision here. Now probability A is probability of happening of event A. The formula can be written as favorable outcomes of event A divided by total number of mutually exclusive, exhaustive and equiprobable outcomes of a sample space, that is equal to m upon n. So the formula for calculating probability, the first formula depending on the mathematical definition, is m upon n, that is favorable outcomes divided by total outcomes. There are certain assumptions made for the validity of the mathematical definition of the probability. So let us check them out one by one. The number of outcomes in the sample space of the random experiment is finite. The most important assumption here is that number of outcomes of a sample space are finite. That means this definition applies only to the finite sample space and not for the infinite sample space. The second assumption that the number of outcomes in the sample space of a random experiment is known, means which outcomes and how many outcomes are there must be known in advance. If you don't know that, there is not a chance of calculating the probability, because the n, the total outcomes, must be known. The outcomes in the sample space of the random experiment are equiprobable. Now this is an important assumption, that all the outcomes of a sample space must be equiprobable. Every outcome should have equal probability of happening. No outcome should have any more or less probability of happening than the rest of the outcomes. Next are the limitations. Now this is also important, the limitations of mathematical definitions, how mathematical definition falls short of its importance, how it cannot be used for certain cases. We will start it one by one. The probability using this definition cannot be found if there are infinite outcomes. Okay, if the outcomes are infinite, we cannot use this formula for calculating probability. The probability using this definition cannot be found if all the outcomes of sample space are not known. Just not about all the outcomes, but if some outcomes, even if they are not known, we cannot calculate probability, because the assumption is all the outcomes of the sample space of a random experiment must be known. Even if a single outcome is unknown, we cannot use the mathematical definition. The probability using this definition cannot be found if all the elementary outcomes of sample space are not equiprobable. That means if the elementary outcomes, the outcomes of a sample space, are not equiprobable, we cannot calculate probability using this method. The word equiprobable is mentioned in the definition itself. Now the equiprobable word means probability itself. That means that we have used the word probability in its own definition, which is quite confusing. That means we are defining probability using the word probability itself, which in itself is an incomplete definition. So that is one of the major limitations of the mathematical definition, that we are defining probability and still we are using the word probability indirectly in itself. So it is confusing. Now, moving on to the last part of this tutorial, we have derived some important results. We are not giving any proof for that. It is possible to prove them, but that is not part of your syllabus here. So I am just stating some important results. These are the results which you should keep in your mind. Remember them, because for solving the sums of probability in this chapter, you will need these results many times. The first result is that the probability of happening of any event, let us take event A. So the probability of happening of event A always lies between 0 and 1. Why? Because 0 is the minimum amount of probability and 1 is the maximum amount of probability, and any event lies between these two values. So the probability of any event can be 0 or 1 or something in between. It cannot be negative, it cannot be more than 1. The probability of an impossible event is 0. Therefore, probability of null set is 0. So that is the minimum probability. An event can be impossible, there could be nothing more than that. So the minimum amount of probability is 0. Then the probability of certain event is 1. Therefore, probability of the universe is 1. That means maximum to maximum certainty of an event is certain event. That is, the probability of certain event is 1. That means the maximum amount of probability could be 1. Therefore, the probability of happening of an event is always between 0 and 1. Either it is impossible, or it is certain, or it is something between. So the range of probability is 0 to 1. Probability of complementary event A dash of A is probability of A dash, that is equal to 1 minus probability of A. Now the concept of complementary event is that it is everything which is not part of A but is the part of the universe. Now the probability of universe is 1 and the probability of A. So when we deduct probability of A from the universal probability, we get the complementary probability. So 1 minus probability of A will get us the probability of A dash. But we can swap the sides. We can also get probability of A is equal to 1 minus probability of A dash. If A is a subset for B for two events A and B in the sample space, then PA is less than or equal to PB. A is a subset of B, so probability of A is either less or equal to probability of B. And second thing, when we find the difference event B and A, we just deduct A from the B because A is a subset of B. These are still some important results which you need to remember. Okay, A dash intersection B dash can be converted as A union B whole dash, the answer of it, because it is a dash, that's a complementary. So whenever we get events with a complementary symbol in it, just deduct that event from 1. So A union B dash is 1 minus A union B. Next, A dash union B dash, so we just convert it into A intersection B the whole dash. You just see here in the first proof, A dash intersection B dash became A union B the whole dash. So the dash was taken outside of the bracket and intersection was converted into union. Similarly, in the A dash union B dash, the dash was taken outside of the bracket and union was converted into intersection, and A intersection B the whole dash means 1 minus A intersection B. Next proof is something which actually I have done beforehand, but I am still giving it again here. A minus B can be written as A intersection B dash, or it can be written as A minus A intersection B, or A union B minus B. So any of these four formulas you can use to calculate the difference event AB. Similarly, to calculate difference event BA, we can write A dash intersection B, or B minus A intersection B, or A union B minus A. Okay, it is something similar, just swapping A with B's. And the last one is 0 is less than equal to A intersection B is less than equal to A is less than equal to A union B is less than equal to PA plus PB. This last point is sometimes asked in MCQs or 1 mark sums, where you need to arrange the given values into ascending or descending order. So this is the order in which you are supposed to arrange them. If it is ascending, then 0, intersection, A, union and addition. If it is descending order, then addition, then union, then A, then intersection and then 0. So you can arrange them accordingly. So with this I end my today's tutorial here. In the next tutorial, I am going to start with the sums based on the mathematical definition of the probability. Till then, study these theories properly, write them down in your notebooks, and if you want, you can even take a look at the illustrations which follow in the textbook, because I will be starting with the exercise 1.2 in the next tutorial. Till then, stay tuned, stay home and stay safe.